Welcome back to the Rooted in Resilience podcast. Today we had the pleasure of speaking with Dr. Tom Cowan, whose motto happens to be question everything. So right away, I know I want to talk to this person. So in today's conversation, we go over how a lot of what we've been taught to believe in science classes, or I guess what you would think that, most of the medical world is based on, might not actually be fully accurate. And he kind of explains a lot of different reasons why he believes this. So this involves things like, are vaccines real? Why do we actually get sick? Does our DNA matter? Do all of our organs have cells? So definitely an interesting conversation, and make sure you stick around to the end where we get Dr. Tom Cowan's main takeaways of what you can do in today's world to be healthy. And then Ashley and I have our sister chat to review everything. So hope you enjoy this episode, and make sure you hit subscribe so you can be notified when we release new episodes.
What's up, guys? Welcome back to the Rooted in Resilience podcast. Today we are joined by Dr. Tom Cowan. He says to call him Tom, and we are just so excited to talk about all things kind of Western medicine, what could be kind of incorrect in the old biology view, and how Tom views the human body and how we achieve health today. So, Tom, could you give us a little backstory as to kind of how you got to where you are today, why you gave up your medical license, and just a little bit of your backstory.
So I grew up, in sort of conventional sort of way, and, nothing particularly special. Went to college, didn't really like it very much. And all I knew was I didn't want to be a doctor. And so then I joined the Peace Corps and taught gardening for 2 years. And then I learned while I was in Swaziland that there was other ways of being a doctor than what I had heard growing up. A lot of my family friends were, parents' friends were doctors. So then I realized that there was a different way to be a doctor. So then I could go to medical school. So I went to medical school as a kind of a spy almost. I learned what I had to learn and got my license to practice, and actually worked as an ER doctor for years just to help supplement my income. But I sort of never really believed it, even from 45 years ago. And then over the years, I've just tried to figure out what's real and what isn't. And I discovered that almost all of what we learn in medicine isn't real. And there's a whole different way of looking at it. So then I wrote books. The heart doesn't pump the blood, and cancer hasn't got anything to do with genetics. And vaccines are neither safe nor effective. Viruses don't exist. Bacteria don't cause disease. And a few other things, but that's basically.
Yeah. So your kind of motto is question everything, right?
Pretty much. I mean, it's more, I think the main thing, if I'm sort of quote, selling anything is, and I didn't particularly realize that this was what I was doing until retrospect, but the first thing I would say is you don't have to know what is true to know that something isn't true. And that's a mistake that a lot of people make. And the easiest example I can give people is if you've ever looked into how clouds form and rain develops, it's very complicated because the water is heavier than the air. So why don't clouds fall down to the ground? But they don't. Somehow they float around in the sky. So anyways, I've looked into it, and I don't really know why the clouds form at this point. But if somebody comes along and says, I know why there's rain, it's because there's elephants flying up in the sky, pissing down on the ground. The way to go into that is to ask the person everything that you can think of about that situation. How high up are the elephants? What do they look like? Are they pink elevated, brown, gray like usual? Is it like 10 elephants? Is there hundreds of elephants? Whatever. And then actually, and I did this with pretty much every patient. This is how person came in, they told a story, and then I would repeat the story back to them. Is this what you mean? It doesn't mean I believe them about the elephants. It's just that I need to know how they arrived at that conclusion. Then I could, for instance, if they tell me they're a mile up, I could take a helicopter up or an airplane, go a mile up. Not a single elephant is in sight, even if it's pouring rain. So then I know that that theory doesn't work, or that hypothesis is incorrect. Doesn't mean I know why there's rain. I still don't know why there's clouds form and there's rain, but I know it's not that. And so you can do that with a whole lot of things. And at the end of the day, like Sherlock Holmes said, who I read a lot before I went to medical school, because it's a way of thinking. He said, once you discard all that's implausible or impossible, what you're left with must be true, no matter how implausible it is. And most people seemingly, the other part of this is, if you don't know how something was, quote, discovered or found or demonstrated, then you're not really part of the conversation. And this comes up a lot with viruses. So those two principles. So for instance, I say there's no virus. Person doesn't ask me how I arrived to that conclusion, right? They don't do the first step. They say, how do you explain that my daughter got chickenpox? Now, that violates the first principle, which is I don't need to know how you got chickenpox to examine the claim that there's a virus or not. That's two completely different things. And the other part is you didn't understand how I arrived at that conclusion. Therefore, you have no say in this matter. The third thing is, if you use that example, the principle of that example is that if two or more people get the same symptoms at the same place in the same time, right, or animals, that proves it's a virus. That's the principle behind, if my daughter got chickenpox when she was with somebody who allegedly also has chickenpox, that proves it's contagious and that it's a virus. That's the theory. That's the principle. But if you think about it, if you put 100 rats in the basement and then you put rat poison, and maybe you didn't know they put rat poison, the next day 10 rats all bleed to death and die. Right? Same symptoms, same place, same same everything. Next day 10 more rats. Next day, 100, the rest of the 100 die. You conclude, therefore, rat poison is a virus. Right? And it's ridiculous, because that way of thinking is not how you demonstrate that there's a virus. And they made this mistake over and over again. They said, you have sailors on a ship, right? And then one has their teeth fall out and they go into heart failure and die. And then the next one does, and the next one. So they said it's contagious, must be some germ. So they quarantined them and they all died. And somebody said, I wonder, maybe they need to, if you give them a lemon, it'll all go away, because they had scurvy. And so if you use that principle, you end up A, making mistakes, which are easily shown, and B, hurting people, because when they're, have scurvy and need a lemon, instead you quarantine them and kill them, which is exactly what happened here. So those are the principles that I work under. You got to know how you arrived at that conclusion. You got to know the details. You got to know what they did.
So it seems like
you have to examine the claim You don't have to know what is true. That comes at the end.
So it seems like you have just a different way of thinking than a lot of, standard Western medicine. It seems like
No kidding.
humans don't like not knowing, right? And so for the unknown situations, we kind of conceptualize and create some concepts and ideas so that way we don't have this fear of unknown. I think that that's like a big problem in a lot of Western medicine. And one of the things I really appreciate about your work is you talk about so with Western medicine, we have to break it down to like the main principles and what you guys are taught in med school and the ideas in old biology. And so something I appreciate about your work is you bring up, wait, what if these like standard principles that we're taught as quote truth and fact, what if these are incorrect? How can we then believe everything that comes after that? So can you briefly touch on some of the issues that you have with old biology, touching on the work of Gilbert Ling and, pumps across membranes, and like other cellular structure ideas? So these things that we've kind of conceptualized in order to avoid the fear of not knowing.
So, one of them, and basically it's not just biology and medicine, it's physics and economics and politics and a lot of things. Not bridge building, because the bridge, if you don't build it right, it falls down. But the people who think and make models, they're just talking about theoretical models. So one example is one of the great conundrums in biology was how living beings like us or other animals or mammals live in a salt-rich environment, but yet the inside of our cells is essentially deficient in salt, sodium. So how does that happen? Because we know that if the inside of the tissue or cell has high sodium, it's dead. Because the fact that there's a charge in cells or tissues has a lot to do with the unequal distribution of sodium and potassium. In other words, if you draw a cell, let's forget about for a minute whether there are even cells, because that was a theory as well. But let's say for a minute there is. Then it's outside of the cell, high sodium, low potassium. Inside of the cell, low sodium, high potassium. And because there's a difference, there's a charge across the membrane, which creates voltage, which creates life. So the biologists wanted to figure out how that happened. How did this cell keep the sodium out and keep the potassium in? And so this was literally decades, maybe a century of research to try to figure out this central issue in modern biology. So then they figured it out. They said there's a pump embedded in the membrane, and the pump, it's like a whirligig, sort of like a merry-go-round, and it attaches to sodium on the outside and spins around, or attaches to sodium on the inside, spins around and dumps it on the outside. And the opposite with potassium, it has a slot like a receptor, and the potassium sticks in there, it rotates around, and then dumps it in the inside. And there's about 10 different models or diagrams you can see of this whirligig thing. Now, the first thing about whirligigs is whenever they show you they can't show you a picture of it, and they show you a whirligig thing, and then there's 10 different whirligigs, it means nobody knows what the thing really looks like, because they have 10 different artists who came up with the model. It's just like a unicorn. Nobody can show you a picture of a unicorn, so you can go on the internet and you can find 100 different pictures of what a unicorn will look like, because nobody actually knows, because nobody's ever seen a unicorn. Whereas if you try to figure out what a schnauzer dog looks like, you can just go and there's a picture. It looks like that. And somebody could say, well, I have a bigger one or a smaller one, but basically they all look more or less the same. I know somebody out there has a Schnauzer that looks better than the other ones, but apart from that, it's all the same. So that already tells you this probably make-believe. So then they figure out the proteins that make up the whirligig and the receptor sites and all the rest. And then there's at least 2 or 3 Nobel Prizes in medicine. And there's all these drugs that, digitalis, et cetera, that work on the sodium potassium pump. And the whole Gerson diet is based on the sodium potassium pump. So a lot of things are based on this fact of the sodium potassium pump. So a guy named Gilbert Ling, who's one of the best biologists who ever lived, comes along and says, okay, how much energy is needed to make this pump work? So he figures that out. And then he figures out that in order for the cell to use that much energy, that's 30 times the amount of energy that it needs to do everything. So it's like having a mortgage of $30,000 a month and your income is $2,000. Eventually you run out of money and you can't do it. So the energetics didn't work. But then the other thing he did, that the cell or the tissue is like Jell-O. It's like this organized, structured water, like Jell-O. And like Jell-O, it doesn't really have a membrane, right? It's got a slightly thicker skin. So he peels off the skin of the cells. You could get certain cells, peels off the skin, and lo and behold, the sodium potassium is exactly the same, proving that the membrane has nothing to do with the sodium and potassium distribution. Because if you take off the membrane, it does the same thing. And so anyways, there was a 200-page book, I think it was his PhD thesis, proving that there's no such thing as a sodium potassium pump or any receptor on a cell membrane, like an opiate receptor or an ACE2 receptor or a serotonin receptor. There's no pictures of any of them. There's no possible way they exist because the same thing happens if you strip the membrane out. And just to be clear, I didn't say that opium doesn't have an effect on cells. I'm saying that it's not because there's a receptor. So there's no ACE2 receptor for a SARS-CoV-2 virus because A, there's no virus, and B, there's no receptor. So the whole theory is just baloney. And then in that one, you can actually demonstrate how it does work. It turns out the lattice structure of the water in the cell is made so it perfectly fits to potassium, and the sodium doesn't fit. So the sodium gets pushed out of the crystal, and the potassium sticks in the crystal just because of normal physical properties. And so all you have to do is make the crystal, and then the sodium potassium will do its thing, which is a much more elegant and efficient system because you don't need any energy to run, to create voltage, electricity, electromagnetic force, or life, which is how you would expect. If I was God, that's how I would make it. Not with this imaginary pump that needs, and people do this with, the deuterium nanomotor that, spins around. And here's another way you can tell. They say there's a deuterium nanomotor that spins around and makes ATP, and it spins at 3,000 RPMs. You hear that all the time. So if you're a podcast or an interview and somebody says that, you should ask them, are you sure it doesn't spin at 2,999? No. Yeah. I mean, it's sort of like 3,000. How about 2,500? Yeah. 1,500. Because you can talk them down to about 100. And then they'll draw the line. No, it's over 100. It's got to be over 100. And the reason why they can't give you a number is because nobody ever measured it. They just guessed well, there was this much at the end and this much in the beginning, so the motor must be going at that speed, otherwise you wouldn't get that much at the end. And they don't see the motor, they don't see it moving, they don't see it rotating, they don't know how fast it's going. They make up all the steps.
Yeah, I think these questions are really fascinating. And being two people, I mean, we went through basic biology and chemistry and all these different classes in high school. But then beyond that, I mean, there's a little bit of it in college, especially if this is your focus. But you're not really ever taught to question these theories that are making up the greater picture of, how we conceptualize disease or health in the human body, or what the inside of the human body even looks like. So based on your knowledge here, with kind of discarding a lot of these assumptions, I'd say, what does the inside of the human body actually look like?
Because I would say like a textbook makes you look at something and you just see a bunch of those little cells that you show in a biology book. You've got one mitochondria, one nucleus, endoplasmic reticulum, membrane, pumps, receptors. So like you view the body as just like billions and billions of those. So what is your, like Sarah's question?
Yeah, if it's not that, then what I know you don't have to know the truth to know that that's not true. But then what would you say kind of is your working theory then?
So it gets into the question of what are we made of? And so I often turn that around to people and say, so what is the human being or any animal made of? And I get some really interesting answers.
Water.
Anything else?
We have a lot of microbes in us. Tissues, organs that are made from smaller structures.
So, and believe me, I get all kinds of answers like light and consciousness and electromagnetic fields, and all that may be true. But if you really want to know about the world, anybody listening, here's my suggestion. Because if you start somewhere that may or may not be true, you're off on a bad tangent already.
Western medicine.
Tell me if you agree with this. So we're going to figure out what a human being is made of. Okay? And so I'm going to take it step by step, and you get to say, I don't agree with that. And if you don't, then we got to work on that step. Okay? I think a human being has head, eyes, ears, throat, arms, legs, few other things. You agree or not?
Agree.
Agreed.
Now, I know there's some people who don't have two arms, but more or less. And so, as far as I know, everybody I've asked that agrees, and every scientific discipline, traditional like Chinese medicine and Ayurvedic and all, they all agree with that. We got heads. And if somebody doesn't have a head, that's a problem. So underneath that, we have things like liver, kidneys, heart, nerves, blood vessels, retina of your eye, those kind of things, organs.
Bones, muscles.
Now, the question is, how do you know that those, like if you kill somebody, and you cut them open to see a heart, how do you know that the killing process didn't create the heart? That's the question you have to answer. So, I mean, it's a good question, but there's things you can say. First of all, I've happened to have seen people who weren't dead, who got like shot, and I could see their heart and their liver. And I don't think it just created in the time they got shot. I mean, it's possible, but I don't think so. You can also see them on an X-ray and a CT scan and an ultrasound, and you can kind of feel it, And I don't think there's any doubt that we have all those organs, 188 of them. And in fact, again, applying everybody I've ever seen or asked agrees with that. And Chinese medicine and Ayurvedic medicine in particular both agree, and they actually put a lot of stock in the organs. The liver, the qi flowing through your liver and the adrenals, et cetera. 188, different organs, different tissue types. By the way, 144 of them, they say have cells, and the other 44 they say don't have cells. Like the lens of your eye doesn't have any cells. It's called a syncytium, which is an acellular structure. Okay, you agree with that? We got organs and all that?
Yes.
Okay, let's take one of them like your liver. What is the liver made of?
I feel like with Western medicine, you would just say a bunch of differentiated cells. Particular to the liver.
Yeah. So here's the question. How do you know that liver has cells? You ever seen a cell in a living person? In a liver? You think anybody has?
Something that you bring up is like the imaging technology that we use to look at these cells kind of just removes things from living species, and you have to do all of this dyeing and heating and cooling.
Right. That's why the first thing I said was you need to know how they found out there were cells. Right? Oh. Because if you don't disrupt the liver, we don't have the instruments to see liver cells. You don't see them on an X-ray. You don't see them on an MRI. You don't see them on an ultrasound. You don't see them if you dissect the liver. You don't see liver cells. And even if you dissected a cadaver, the question is, how do you know? You don't see liver cells there either. You have to remove a piece of the liver, cut it into really small pieces, dye it, stain it, and then use a microscope to see it. Now, it could be that they're there and we just don't have the technology to see it. That's possible. But it could be that those techniques create the structures we call cells. And by the way, I'm not saying that's true, but it's possible. Because we know that, like bacteria, if you threaten them, they form spores, or they form bacteriophages, which are little structures that are created from the process of stressing a bacteria. So it wouldn't be that unusual for a liver to, like, why would it break itself up into compartments? Why not just have a homogeneous tissue? It would be much stronger, more efficient. Communication would be easier instead of like office cubicles. Then they have to have the right distance apart. They have to communicate. It's just kind of a mess. Like, why would you do that? Now, I'm not saying that proves anything, but it makes you wonder whether the process that we do to find the cells creates what's called an artifact, not there in real life. Now, here's the other thing. Nobody before 1858 ever said that we're made of cells. There's no mention of cells in Chinese medicine, Ayurvedic medicine, Native American medicine. They didn't talk about cells. And it could be because they didn't have the instruments, but they just didn't think so. And so somebody made it up. Turns out a guy named Rudolf Virchow, who's a German guy. It's a whole story about him, which I don't need to get into, but he said, I see onion cells under an onion, when I dissect an onion. Therefore, humans are made of cells. Shit. Like, that doesn't make sense. Anyway, so that got started. Everybody at the time said, it's nuts. Living things aren't made of cells. But anyways, he had a lot of political influence, and that won the day. Okay, so then came the cellular theory, and all of modern medicine is based on, you take a biopsy, you look at the cells, the cancer cells, then you got cancer. But here's the interesting thing about it. They say, okay, cancer they got these cells, and the cells are growing, right? So why does this matter? Because first of all, if you take like a liver, the only time you really see these cells is at the periphery, at the edges of the liver. The middle is more of a homogeneous mass. So, and you do then see cells, more of them when the person has liver cancer. So how about a different way of looking at it? The liver is a homogeneous tissue, and if you poison it, it puts the poison into receptacles like garbage cans, which are called cells. And just when it's normally dying, there's a kind of turnover. And the edges of them, it sloughs off little pieces of dead liver just normally. And that's what we call liver cells. And if you poison the liver more, you'll get more of these garbage cans. Just like you have a house, you put a bunch of garbage in it, you get a garbage can. Now, then they say the liver cells, cancer cells, they grow and divide. But in order for a cell to grow and divide, it has to have, they say all human cells have 46 chromosomes, right? 23 pairs, and they split down the middle, and then you make new cell. But a cancer cell doesn't have 46 chromosomes. That's how they see it's a cancer cell. It's disorganized, got 100 broken ones, 20, whatever. It's not a normal cell. It's called an aneuploid cell. So there's no way that can divide. So that tells you already the whole theory of cancer derived from growing cells is nonsense. The cancer cells aren't dividing. They're just being put into receptacles, eventually called a tumor. Now, that is really important because they say, how does it go from like the breast to your liver? Right? So they say the cells divide and then they crawl through the bloodstream and they land on your liver. Okay, well, take a look at my blood, see if you can find any cells. Can't find any cells in the blood. Why not? I don't know. They're not they're not enough to see. What do you mean they're not enough? There are all these cells. You said they're spilling out in the blood, like with their suitcase going to the liver. No, can't find them in the blood. Nobody has ever found them in the blood. It's like if you have garbage and you put it in your house, then you make a garbage can, right? And then you keep more garbage because you're a dummy, and then you put it in the spare bedroom. The garbage did not walk from the garbage can to the spare bedroom. It's just that you had more garbage. So so that changes all of oncology, right? Because you're not catching it early so keep it from spreading. It doesn't spread like that anyway. It spreads because you have more garbage and you have to find a new place because there's not enough room in your liver anymore. And then you put it in your bones and then your other places. And so it tells you everything you need to know about managing that disease, which has nothing to do with what oncology says. All right. So then we go back. Okay, let's say there's these cells, at least 144 of them, supposedly. What's inside there? Well, you got all these things, ribosomes, endoplasmic reticulum, all these things. But it turns out that you can't see any of them except under an electron microscope, and they're all artifacts. One of the ways you know that is because every picture of a ribosome, you can't see it with a light microscope. You have to remove the tissue. You have to freeze it to 120 degrees. You have to stain it with heavy metals. You have to, grind it up in a blender, a whole lot of stuff. Then you see these perfect circles on a two-dimensional picture. Now, I ask people, if you had an orange, right? That would be, if it was a circle on a picture, it was a sphere in real life. You took an orange and you ground it in a blender, froze it to 120 degrees, dehydrated it, made it into a powder. What are the chances that every picture would be a perfect circle?
Not likely.
0. So this perfect circle of a ribosome didn't exist in the living organism. it's, as Hillman proved, it's an artifact. It's a gas bubble that forms when you do that stuff to tissue. You form little gas bubbles in it, and they stain, and then you call them ribosomes.
Because we're artificially removing an organism from a living being and analyzing it when it's just completely dead and taken away from its normal context. And also, like you said, blended and frozen and dyed and stained.
Right. There's
And then making
nothing to be
assumptions
learned
on
from that procedure about
I see.
what existed or functioned in a living organism. Nothing. And if that's true, which it is, and see, here's the thing. If you talk to somebody, are there ribosomes? Well, ribosomes are really important right now because that's where mRNA is made into protein. So the mRNA that you're supposedly being injected can only be made into protein if there are ribosomes. And since there are no ribosomes, there's no way that you're making spike proteins with injections of mRNA. No way. In fact, nobody has ever measured the level of spike protein in someone who's had an injection or not, which would be easy to do, but they conveniently forgot to do that.
So then where is the mRNA going?
It's probably nothing. It's just garbage. They say that the ribosomes are the site that the mRNA is made into protein, but the ribosomes don't exist. And not only that, but the people who did this stuff, they love to like mock people. So you know what ribosome means? Rib, right? R-I-B, of the soma. That means body. So the place where you are made is the rib of the body. You ever hear that before? Adam and Eve?
Oh, okay.
Eve was made from the rib of the body of Adam.
Okay, yep.
just to make sure they can make fun of you a little bit. Like, get it? Like, we know this story here, but we're just messing with you. Anyway,
Wow.
so, and the whole thing that genes make proteins. So they say one gene makes one protein, right? That's the theory. And if you get a messed up gene like a mutation, you make a funky protein and then you get cancer or you get MS or something.
Because
right?
It's your genetics. It's all your genetics.
Your genes got messed up. So now we're going to do gene therapy and test your genes and give you genetic tests. And you should eat this food because it helps your genes express themselves right, all this stuff. So right, that's the whole thing. So you know how many proteins there are in a human being? Approximately. About 150 to 200,000.
Okay.
You know how many genes they say they are?
Millions?
20,000.
Oh.
So here's the question.
Orders of magnitude.
You see, the problem with scientists and doctors is apparently they don't know arithmetic. So if they say one gene makes one protein, all the proteins are made by the genes. How do 20,000 genes make 200,000 proteins? Where are the under 180,000? Where's the code? Well, right. They get rearranged. What do you mean they get rearranged? They're not supposed to get rearranged. Yeah, they get rearranged. And here's another thing. Every cell, supposedly, or tissue, has different DNA. So if somebody says it's your DNA that's making this, you should ask them, you mean my liver DNA or my... How can it be the basis of heredity when every tissue of your body has a different code, and it changes all the time? No, I have the same DNA from my mother, half from my mother. No, you've got different one every 10 minutes. So the idea, and not only that, so the DNA is in the nucleus of the cell, right? You can actually see nuclei in tissues, and the nucleus has a membrane around it called the nuclear membrane, and you can stick a probe in tissue, and the pH is different in the nucleus than in the cytoplasm, the watery part, right? That's measurable, which means that the hydrogen ions can't equilibrate from the nucleus to the cytoplasm, right? Otherwise, they'd be the same. So the question is, if the DNA is made into RNA in the nucleus, which is what they say, and then it gets out of the nucleus and goes to the ribosomes, the imaginary ribosomes in the cytoplasm, how does the mRNA, which is, let's say, 1,000 times bigger than a hydrogen ion, get out without letting the hydrogen ion get in? It's like, how do you build a mosquito netting that lets elephants out, but the mosquitoes can't get in?
Science.
So then you have a new whirligig, and the whirligig attaches to elephants and spins around and deposits the elephants on the outside. And by the way, the mosquitoes haven't figured out how to fly in the whirligig, even though it's huge, 1,000 times bigger than a mosquito, but they won't fly in the whirligig to go into the cell because they don't like that. And so that's how it works. And by the way, we don't have a picture of the whirligig. We just know it's there because it must be there because the mRNA has to be made in the nucleus, and it has to get out because it has to go to the ribosomes, and they're not in the nucleus, so it's got to get out somehow. So there must be a whirligig.
Honestly, this is all very confusing, but I think it's funny that basically this is all stemming from simple questions you're asking that are kind of breaking down these foundational ideas. And then you start to kind of see holes, like the big elephant hole versus the mosquito not being able to fly in a lot of this working theory that we have been taught to believe.
Too much money is based upon these accepted
I mean, and artifacts. I guess for our audience, who's probably sitting here scratching their heads at this point, like what's even being said, what are then, more practical things to take away from these questions? Like let's say if bacteria doesn't cause disease, or, it's not your genes that are causing the cancer, then what is it that you believe is the reason that somebody does get sick?
So, it's also not enough to say, so bacteria don't cause disease. So where did I get that from? It's very simple. If you want, the problem is when people talk science, they somehow lose their common sense. So that's why I often talk about common things. Like, let's just say, if you're on a quest, is there such a thing as a hammer? Right? You know what I mean, right?
Mm-hmm.
Okay. How would you find a hammer and show me that it's real?
I would go into my garage. Go look for it. I don't know.
Where would you look for it?
The toolbox.
Toolbox. Let me see if you agree with this. I would go to the ecosystem where I would expect to find the hammer. Right?
I suppose.
And then I would look. And what would you do next, especially if you want to find out what a hammer is made of and what it does?
Test it.
Well, you got to do something first.
You would break it.
Grab it.
Take the hammer out of the toolbox.
Yep.
Okay.
Right? What if I said, oh, don't bother with that. Just take the toolbox and smash it against a nail, and that'll tell you whether hammers bang in nails.
That's silly.
Right? Because you don't have a hammer. You're trying to find. You might not. That might tell you whether toolboxes bang in nails. What if I said, the way to find out what a hammer is made of is take the toolbox grind it up in a big blender, and then analyze
That'd be
Hammer's lost.
it. You don't have the hammer.
Yeah.
Okay, how about a frog? Do you think there are frogs?
Yes.
Yes.
Tell me how
I've
you
seen-
know, how you would demonstrate there's a frog.
I have caught a frog.
I would
and
go to
held
a-
it with my hand.
I would go to a pond
Yes.
Right.
and a lily pad.
Go to a pond, find the frog. If you're a mean person, you kill the frog and find out what it's made of. Or you could just watch the frog and see, does it eat flies, etc. How about this? Take a big scoop of the pond water, may or may not have a frog, grind it up in a blender, and then analyze it and see if the flies die in the mix.
Silliness.
Right. So we all know that in order to demonstrate something, you do something called isolation, right? You separate the frog or the hammer or the nanoparticle, doesn't matter the size. The size may tell you, how you have to do it. Like you have to separate a frog differently from a hammer, right? Because they're different. But you do the same thing always. Now, with viruses, you go to the ecosystem where there's viruses like your lungs. Nobody has ever found a virus. Nobody. And they say that. They say there's not enough to find. So you can't study. You can't study. Now, bacteria, you can. Right? You can go to a pond or a wound or something and your skin or your bowels, and you can find bacteria. Now, how do you know that a hammer bangs in a nail?
I've done it. I've seen it.
Yeah, but describe the procedure.
Nail in wall, use the grip of the hammer and hit the nail with the end of the hammer.
Got it. Only the hammer, right?
Yes.
Now, if I said to you, how do you know it's not just your hand going like this that makes the nail go into the wall?
Well, partly it is because you
Yeah.
have to have that force.
Well, but you could do a control and do like this
Oh, yeah.
and see if the nail goes in the wall without the hammer, right?
Probably not. Probably hurt.
And if it does, then it's not the hammer, it's this. And if it doesn't, which is what I suspect, then you know this is part of the process, but you got to have a hammer or it doesn't work. So you can do that with bacteria. You can take the bacteria, you can expose another person to the same bacteria as found in your lungs with somebody with pneumonia and see whether they get sick. Right? And you know what they find? There is no reported case in the medical literature of any bacteria introduced to other human beings or animals in the normal way. Like sometimes they inject it into your brain and then they don't do a control. Like you'd think they'd inject, salt water or something. They don't. They just inject 100 cc's of bacteria with some other stuff in it, like broth, and into your animal's brain, and they say, see, animal got sick, which is ridiculous. But in a normal way, not one study has shown that bacteria make anybody sick. In fact, polio, they proved it was a contagious viral disease. They took a child who had paralysis, they didn't know why, ground up their spine, filtered it, injected about 20 cc's or so of ground up filtered diseased dead spine into 2 monkeys' brains. They didn't do a control, like they didn't inject nothing. One monkey died, the other got paralyzed. That proved polio was a viral contagious disease. 1908. That's ridiculous. That's nuts. And then from then on, that we proved it. And if you ask your doctor, who proved polio was a virus contagious disease? Oh, they don't know. Because you have to go back and find out. And they don't tell you that in medical school. You have no idea what happened. So same with bacteria. So what are bacteria doing there, right? They are there, unlike viruses, which you can't even find. So it's the same as in nature. If you have a dead tree, you get bacteria, right? And fungus. They eat the dead stuff and recycle it. So that's what they're doing in us. They recycle dead and dying tissue. So the question is, how do you get dead and dying tissue? To a certain extent, it always happens, just normally. But the way to accelerate it, which is what we call sickness, is poison the person. And then they get more dead tissue, just like trees or frogs or anything. And then they get more dead tissue, and then the bacteria come to help you out and eat the dead and dying tissue to recycle it. And we blame them for causing the disease. And that's how you get sick, because we're made of water, which essentially accepts, information from the sun and from the electromagnetic field around us. And if that's in error, either it's the water is poisoned or the field is toxic, or the emotions or thoughts or ideas or 5G or radio waves or unnatural electromagnetic fields, then you make bad information, you dead and dying tissue. They spew off parts which are mistaken as viruses, and the bacteria come and eat it. It's very simple.
So then going back to the question of like, what should the inside of the body look like? So we talked about, maybe cells don't exist and that the liver is instead just a homogeneous tissue. So then in an ideal body, can you talk a little bit about structured water coherence and how the structure of that water impacts how all of the different components are functioning and how changing that will then impact the health of that person?
So each organ is a unique mix of water and certain salts and proteins which structure it in order to create a function. Just like the lens of your eye has to be clear so you can see, right? So it uses proteins and salts that create a transparent structure so the light can see. And the liver is different. So each of them has its unique shape. And they're like Jello molds. And every Jello mold is a different, perfect crystal for that tissue base and for you. And everybody's got a little different liver structure and, like mesophase, they call it, or liquid crystal. And insofar as you have a perfect crystal, because you have the right material to make it out of and the right field telling it the instructions, that's what we call being healthy. And all cultures have known this because they use things to cleanse your gels, your water. So there's sweat lodges and fasting and purging and enemas and herbs for detoxing, all these things to essentially clean your pond. And it's like I say, if you had poison grapes dissolved in your Jello, you would heat the Jello up. That's called a fever. Then you would make the Jello run. That's called mucus. Then you would get rid of the grape, and then you would make a new Jello. That's how we get sick. If you don't want that, don't put poison grapes in your body.
Right. I think that's, hard in the society that we're living in, where, we're exposed to a lot of different things that are unnatural. And I'd say the world has a lot more of these poisons, that we're having to combat. And so what is interesting is that we see all these different diseases, popping up with names. So diagnosis, we're giving people a different diagnosis, but it seems like what you're saying is that it all comes back to basically this is the body's way of, trying to handle it. Maybe there's an inflammation increased, And if we were to improve the body's natural detoxification, utilizing either these things you mentioned, like the herbs or the fasting or the enemas, and get back into a natural environment, we could potentially see these air quote diseases reverse.
Yeah, because the diseases don't exist anyways.
Right.
I mean,
That's what I'm
and
hearing.
it's so obvious, even though in medical school you don't catch on to the rap. But for instance, if it's like a disease like rheumatoid arthritis. So rheumatoid arthritis, usually women, not always, they don't feel good, they're tired, they have sweats, their joints are swollen, they're achy, and they have rheumatoid factor, an antibody in their blood. That's how you diagnose rheumatoid arthritis. So then you have the next person, same age, female, achy, sweats, doesn't feel good, swollen joints, red hot joints, exact same symptoms. Do a blood test, rheumatoid factor's negative. So what do they have? They have negative rheumatoid factor rheumatoid arthritis. And I remember hearing that. Wait a minute. You just told me that the hallmark of rheumatoid arthritis was this rheumatoid factor antibody in the blood. This person has the same symptoms and they don't have a rheumatoid factor. Yeah, but it's because it's rheumatoid factor negative rheumatoid arthritis. But that's ridiculous. That's like that. There's no disease rheumatoid arthritis. There's whatever is causing the integrity of the gels in your joints to break down.
Okay.
Or there's another one, like we learned that measles, all the symptoms, high fever, mucus, etc. And the hallmark, the pathognomonic finding for measles is these white spots in your cheek called Koplik spots, right? So that's how you diagnose measles. So I looked it up. 40% of the children who have measles don't have Koplik spots. So I remember asking, so they have the same symptoms, same rash, but they don't have Koplik spots. And you just told me in order to have measles, you have to have Koplik spots. What is this? What does this person have? They have Koplik spots negative measles.
Interesting.
You got to have a name for everything.
And then they have the rashes, so measles is maculopapular instead of maculovesicular or just papular or just macular or maculopapular vesicular, and on this classification. But meanwhile, there's study after study. You can't tell the difference between smallpox rash, chickenpox, measles rash. If you line up 100 doctors blindly, they can't tell you which one is which. And so the way they do it is you say, well, this is measles. No, it can't be measles because they had a shot for measles, so it's got to be something else. So it's atypical measles. But when you want an epidemic, you call measles and chickenpox and smallpox all smallpox. Then you come up with a vaccine, and now you can't be smallpox because there's a vaccine. So now it's chickenpox and measles and Fifth's disease. And so they call it, and so they did that with COVID. Used to be you had the flu and pneumonia and atypical pneumonia and chronic fatigue. And so then all those were COVID and then the vaccine. So now you just have back to the flu and all the rest of it. It's
so essentially maintaining proper structure of these things inside of our body. These different tissues have different physical properties of the water and the structure and the coherence. Maintaining that structure ensures proper function. So if there were two individuals, one got sick and one didn't get sick from something in the environment, what would you say would be the difference between those two? That the one individual that got sick had less structure inside their body? Like, what are the variables playing into why someone would get sick and someone wouldn't get sick?
it's all about the integrity of the crystal. And so you interfere with that by dissolving poisons in it, like glyphosate, aluminum, mRNA, nanoparticles, lipid hydrogels, all kinds of stuff. You can insert into your living crystalline structure, and then your body has to get rid of it. So it has to create an inflammatory response, heat it up, dissolve it, and get rid of it. Or you could have, information that's not helpful for the information is the blueprint for structuring the water, for making a leg. It's interesting if you cut somebody's leg, they'll make a new leg. And if you cut their arm, they'll make a new arm. Not cut it off, but, make a cut. And yet they have the same DNA in both of them. So it's not the DNA that determines whether it's a leg or an arm. It's the information field, or what Sheldrake called the morphogenic field. That's where the information comes from. That's where heredity comes from. So if you change that for highly abnormal pulsed single frequency fields like radio waves or 5G or 4G or any cell phone stuff, microwaves, these are not healthy or normal or natural fields that we're all exposed to, and all the stuff they spray in the air and all the rest of it, and fear and emotional abuse and hatred and lies, just all those things create an electromagnetic environment which gives you the wrong signal. So then you create the wrong structure, and then your body in its wisdom has to get rid of it, because that's not the way your leg's supposed to be. That leg is going to hurt. So I dissolve it, excrete it, use inflammation. That's the body's screwdriver in a sense. And I remodel it. But if you're exposed to so much that you can't keep up with the remodeling, you're going to end up living in a decrepit house, which is otherwise known as America or the world.
Yeah, so just speaking from our personal experience, we moved into an older farmhouse that was very toxic with mold. And so that.
But by the way, the mold is probably eating the stuff in the house. Like they used to paint with arsenic and stuff.
Ah, yes.
And so the mold eats the arsenic, and then they blame it on the mold.
I mean, we did have, significant water damage as well in different places, and whether that's still eating the arsenic or whatever was in the walls. And then we were told, this is where different bacteria concentrate, eating the material, like you said, the dead material. They're highly concentrating in that area. And so it's been a journey of learning about, what actually is the problem and why. So I've listened to some of your podcasts before where you kind of walk a patient through like, okay, you've got these symptoms, and then they tell you a story of, what led up to that moment where they started having these symptoms. And so, for myself, I developed a bunch of symptoms, and what was the changing moment for me was moving into this house. So it's almost like pretty clear, what the change was in my environment, in my life, the stress of that, being exposed to new things. And so there is this thing called CIRS, which is chronic inflammatory response syndrome. And basically the working theory here is that the body has been exposed to a toxin, and a large amount of toxins, right? Like we're talking about right now. And it in itself has not been able to properly detoxify it. So now the person is living in a state of chronic inflammation. And so the way to overcome this is to obviously help the body detoxify from what it's dealing with. And so I know
not expose yourself to, toxic crap all the time.
Right. Yeah, exactly. And so, I mean, this is based on the work of Dr. Richie Shoemaker. And so the step one of the process of getting over it is to remove yourself from the environment, right, that got you sick. And That's easier said than done when you've moved into a new house and you've
Right.
got to do all these remediations and stuff. But I appreciate your work because I feel like SIRS is something that I'm going through right now. Just the process of kind of like, what do we do now? But it kind of makes you question everything, because if I took my symptoms to a doctor, which I have, in the past, I would have gotten like 15 different diagnoses of different disease. Whereas if I were to look at my story and what actually happened, I could have just recognized from the beginning, it's because I moved, the stress of that, the environment was bad, all these different things were too much, and that is what resulted in so and so symptom popping up. And so something that's really important to Ashley myself now is getting people to understand the significant impact that their environment and their relationships and their light exposure and the water they're drinking, all of these different things that seem very nuanced, are actually so important in the process of getting sick and also in allowing the body to heal.
Because the body is always taking in information from our thoughts, how someone else talks to us, the air that we breathe, the type of water that we're drinking. And just a note on the house thing, we don't think that like the mold itself caused issues. Like you were saying earlier, bacteria, mold, they create biotoxins as like a defense mechanism.
Yeah.
And so I would say that like the issue in a polluted home could be a biotoxin elevated exposure in an amount that the body is not capable of detoxifying from.
Right. Bacteria and fungus can make stuff that isn't good for you. So they can be a source. It's not an infection, but it's a source of poison. Viruses can't because they don't exist. But it's pretty simple. I mean, it's not rocket science. We're talking about it's just like if you have a pond and you keep throwing poison in the pond dies. And then if you don't want the pond to die, A, stop throwing poison in the pond, and B, flush the pond out. That's not that hard to Now, there's the details are, what do we mean by poison, right? And how do you flush a pond out? So that's where, do you sit in a sauna? Do you run? Whatever, and so a lot of different people have different ideas about that, and that's fine, because if you're thinking properly, a lot of different things will work.
Yeah.
If you're not thinking properly, it doesn't matter what you do, it's probably not going to work.
So part of that detoxifying is also creating the right internal environment and cleaning up the energetic field around us, so that way our body can improve its detoxification and getting those toxins out.
Yes.
So that's going to involve air filters in your home, making sure that you're not exposed to excessive amounts of 5G or Wi-Fi all the time, better thoughts and emotions. And then, in your opinion, what do you think are the best ways to improve the internal environment through water and food? So I would say with water, you'd probably say that consuming structured water is important.
Yeah, of course, you get into what is structured water and how is the best way to make it. And there's a lot of, we sell stuff and we have opinions about that and all that. But those are the details. Once you figure out the principles, you can make this work. It's the people who haven't figured out, they still think they're being made sick by their viruses or the bacteria, or their genes are bad, or bad luck, or something, and they're on a course to get rid of the symptoms. They're on a course to, stop the viruses or take out the tumor cells or something. And it basically never works. It's not meant to work. The whole system is based on keeping people chronically sick, and it's very good at that, very successful. I'm not one to say that medicine is failing. They're not failing. They just have a different agenda than you think they have. Just like the educational system is not failing. Their intention is to keep you as dumb as possible, and they're really good at it. And so they figured out all kind of ways of boring children and keeping them from learning and thinking. and they've perfected it over 100 years, and they're good at it. If you don't want that, like dumb and sick, don't participate. And I'm not a fan of like going to your doctor and saying, don't you know another way that I can heal? Because the answer is no. They don't know. They don't know what you should eat or detoxify or what water to drink or how or whether there's ribosomes or viruses or not. They have no idea. They don't know who came up with those things. It's not their interest. Forget it.
So
then you won't
how
be disappointed.
That's true. Right. Have a different mindset in terms of what it takes for the body to heal.
Yeah. They have a different mindset about biology and life. And it's all based on studying dead stuff.
So then how do you view, so clearly, light, so light from the sun, EMFs, thoughts, emotions, the water that you drink all come in as information to your body to help your body create the right structure and thus the right function inside. How do you view food fitting into this? Same. Obviously, I think that you would say try to do organic or less toxic, but what about like carbs, fats, proteins, and how those interplay into this structure in the body?
I mean, that's kind of complicated. And by the way, I need to really get off in about 5 minutes. But
okay, perfect.
The most important thing is you got to know where all your food comes from. And I'd say any food that you don't know where it comes from is suspect. So either grow it or find somebody who you can look them in the eye and say, how did you grow this pig or this carrot? And it's the same. How did you find this virus? If they don't know, then be suspicious. If they don't know how that carrot came about, I don't know, somebody grew it, then it's probably not good for you. And that's how I would do this. Whether you eat carbs, that's an interesting thing, but I don't think it's the main deal. You've got to eat food that's real food, grown well, processed well. Just check out Nourishing Traditions. That's all you need to do.
Yeah, that's great advice. I think just kind of simplifying things, because I think a lot of what we talked about today was in its own way complex, because you were breaking down systems that people have just, been led to believe. So being able to say, all right, at the end of the day, get some sunlight, eat food that you know where it came from, and let your body, heal itself is a great takeaway.
And where can people find you? Where can people support you and possibly work with you?
drtomcowan.com is the main website. There's also drcowansgarden.com. And we have a clinic now that's staffed by people who understand this new biology. And we're going to start a thing for practitioners soon.
That's great. So great news.
I'm doing stuff prodded by others. Otherwise, I just garden and forget about the whole thing.
That's kind of the approach we're here taking with like 1,000 chickens and lamb and goats. And yeah, it's a lot of fun to kind of just make food and forget about all that's happening.
Yeah. Make food, develop good relations, keep yourself fit, and you'll be probably pretty good.
Sounds great. Well, thanks so much for coming on today.
Okay. Thank you, guys. Had fun talking with you.
Have a good one.
Okay.
So that was a fun conversation with Dr. Tom Cowan. And now we're going to do a little Sista post-show reflection. Sarah, what did you think?
Yeah. Okay. So it was interesting. I think that I just love that. Okay, so if somebody were to listen to that, they'd probably be like, what the heck just happened? But what I love the most about it is that he's not really claiming to know everything at all. Like, he's actually not claiming that whatsoever. So on surface level, it might be like, wow, this guy thinks he knows everything. But reality is he's literally just asking questions, which is kind of putting holes in all of these theories that we are taught and just naturally believe because that's what we're told is true. But I appreciate him a lot because he is the one standing there with a little red flag being like, wait, what? That's, does this actually work this way? How can you prove it? Does this actually make sense? And then when you open up those questions, there's so much more room for discovering more and learning new ways to actually heal the body. And so that's my main takeaway.
My main takeaway is like, it's clear why medicine isn't working.
Oh, I mean, for sure.
When it's based on like when you go to the fundamental level of what it's based on, and Tom Cowan bringing up all these points about how those are just artifacts and they're theories, like the idea of cell and ribosomes and membranes and receptors and the whirligigs, they're all theories and they're not necessarily proven facts. How can you believe anything further downstream?
Yeah. I mean, so I think that doctors and, Western medicine, for a lot of people, bring comfort, and we can't overlook that. And then especially in emergencies and being able to get surgeries and have life-saving things like that, we should never overlook those kind of things. But what he is saying is that a lot of the, symptom to disease to treatment via medicine is flawed. And what Ashley just brought up, that's why it almost never works, or it works, but then it makes something else worse because we didn't ever fully understand what actually was going on and what the body was trying to do. And so when we look at symptoms as the body, actually signaling to us, it's giving us messages, then we can kind of, we really should be like, all right, something I'm doing, something in my life, somewhere I'm living, what I'm eating is not working for me. So we have to make those changes. And if we were to just be able to look at the world and health and disease in that lens, as opposed to, something in your body went wrong and therefore you have this symptom and that's this disease actually, so therefore here's a treatment. That is just breaking down something that we simply, it's way too complex for anyone to understand.
Yeah, I think his view is comforting. I think his view is more comforting than Western medicine that says, oh, it's not your fault, it's your body is faulty, and so take this medicine to help it. Whereas his approach is kind of like, no, your body is intelligent and is taking in information constantly. Like he said, your DNA is changing every 10 minutes because like the environment and the physics inside of us impacts how your body is functioning. So I think it's kind of encouraging that if you give your body the right tools and environment, both internal and external, it does have the potential to heal.
And it's, for me, this almost solidifies more what happened in our own life with the exposure to mold and stuff. And when I say exposure to mold, I know it's not the mold that's making you sick. It's the biotoxins that are being, distributed throughout the environment. And so it's not always that simple to just, move. I think that's a great step. You need to get into a clean and safe environment. And this applies to everything. It's not always as simple as, change your diet. Like there might be other things that you need to do to help your body out. And he provided some examples where he was like, maybe you need to do, fasting, or you need to do enemas. You need to purge the body, sauna, things like that to help the body out. And that's where I think a lot of those biohacking tools can be so beneficial for somebody. But when it comes to the foundations, it is having a safe environment. It's having clean food. And I especially love what he said there is it's not even so much as the nuances of like, eat this much of that food or this much of that. It's really like, do you know where your food came from? Do you know that it is wholesome, clean ingredients? One ingredient, it's a whole food. That is the foundation to somebody's healthy diet. And from there, we can get more into the nuances to achieve different goals.
And you can also understand why two people may have different levels of illness, because if you view it back as to kind of like someone's level of toxicity, so like the amount of toxins someone has accumulated in their body will impact what the best steps forward are to help the body get rid of those toxins.
For sure. I guess I'm still a little confused on, so in the lens of CIRS, chronic inflammatory response syndrome, there is the genetic component there, but I don't think he's saying that doesn't matter. I think he's saying if you change the environment, you can change the expression, which is very true.
100%.
Which is, like when you go through treatment and you change the environment, which is step one, then you're going to change the expression.
So if you want to learn more about Dr. Tom Cowan, I would say that a lot of what he talks about is very similar to the work of Dr. Ray Peat, where Ray Peat has said a number of times proper function impacts the structure. Or sorry, wrong way. Proper structure impacts the function of those tissues. And Dr. Ray Peat brings up the work of Gilbert Ling so many times. And as Tom Cowan said, one of his inspirations is Gilbert Ling. So definitely check out Gilbert Ling's work, who questioned everything in his department. And I think that his work is largely ignored because, like he said, like Tom Cowan said, Gilbert Ling disproved the idea of this sodium potassium whirligig.
Yeah, but I don't think that he has a set in stone views on nutrition as maybe Dr. P has. So I would say, like we already said, that the foundational things is eating whole foods you know where they came from and what works for you. So yeah, that's what we're about here on this channel these days.
All right. Well, thanks for tuning in, guys. And until the next episode, stay rooted in resilience.
I think the grieving part is part of the process. You kind of got to go through that, but then you have to pick yourself up, dust yourself off, and take action. So take action. If this is something that you are, really like a strong feeling this could be something for you, and remember, 25% of the population is susceptible, has that gene. So I wouldn't put it past you if you've tried everything, you're dealing with chronic illness, and you cannot get better.
All right. Well, with that, until next time, guys, stay
Rooted in resilience.